ViTA-SSD is a tool for exploration and finding of patterns on semi-structured documents. In this video, we will showcase our tool with 11,000 aviation incident reports taken from the ASRS dataset. Our tool is divided in different panels. The Document Exploration panel shows a two-dimensional representation of the corpus, where each dot represents a document. Two documents located close to each other indicate that they are related. Documents are colored according to the cluster they belong to. The number of clusters can be changed interactively, triggering changes in other panels. The middle panel helps analyze the content of the cluster. We know that these reports are written using ad hoc abbreviations and technical terminology. In the Metadata Analysis panel, we have information on both clusters and metadata. We can use this for doing different types of filtering. So, for example, we can filter the content of cluster 7. We will see later on how to use this panel for fast identification of patterns. We also know that in the scatterplot we have a stratified sample of the 11,000 documents, which is automatically done based on the number of documents selected to avoid cluttering. We can influence how many documents to sample using this slide bar located on this panel with many other options. Let's assume we are interested in finding incidents on turbulence encounters, seeing if we can find commonalities and differences among the incidents, and what type of patterns we can extract from them. We start our process by filtering the collection, looking for the term turbulence or its technical abbreviation TURB. Let's try to get a big picture of the main groups and see what each one is about. So let's select viewless clusters. We can see from the Metadata Analysis panel that cluster 3 and cluster 4 have 60% of all incidents. So let's investigate them first. Cluster 3 seems to contain documents on moderate turbulence encounters during descent, while cluster 4 seems to contain severe encounters, where passenger and flight attendants may have received injuries. Finally, let's focus on cluster 5, where we see that wake is its main keyword. Clicking on wake shows us in the bottom left table the documents containing wake in this cluster, which confirms that this is about the type of turbulence. This is the type of turbulence generated on the air by a preceding aircraft. It is important to ask now what patterns we can extract. For example, it would be nice for cluster 4 to know when we can have injured people as a result of turbulence. Looking at metadata flight phase, for cluster 4, we see that severe turbulences are more likely to happen during the cruise phase, and as people may not be fastened to their seats, this could lead to injuries. We can confirm this pattern by hovering over cluster 4 and check that almost half of the incidents in this cluster happen during this phase. We can make an annotation out of this pattern. Switching the metadata to flight conditions, we can note two interesting insights. First, VMC, which stands for Visual Meteorological Conditions, and refers when the pilot has good visibility, because there is good weather, seem to be correlated with cluster 5, which is the one about wake turbulence. This is because this type of turbulence happens in clear air. This is in the absence of clouds. Also, something interesting happens with IMC. IMC is the opposite to VMC and indicates when the pilot has limited visibility and has to rely on instruments. We know that the IMC histogram is highlighted as an important metadata value for our current selection of documents, despite of not being the most frequent one. 23% of the incidents happen under IMC. The reason of this is that when we look at the relative frequency of this metadata in the whole collection, and we can do this by popping up the additional options, 9% of the incidents happen on IMC conditions, while for our current selection of documents about turbulence encounters, this is more than twice as frequent. We will show now how we can find more related documents. Recall that we searched for turbulence, not really for wake incidents. Let's assume we got interested in incidents related to proper separation to other planes, especially to B757 aircrafts, like the first representative document of the wake cluster. When we tag this document and shift-click on it, we will retrieve the top 10 related documents. We can read the full documents and select them to be included in the analysis if necessary. For example, document 157 is told by a tower operator and describes how he handled the separation between two big planes. A similar separation issue is narrated by a pilot in another document. We can incorporate any of these unselected documents by shift-clicking on them. Finally, we can also look at the history of all our interactions. This is important to see the sequence of interactions that led us to the patterns we found, and also use these to backtrack to any point in time. Thanks for watching this video.